All right, here's a few more techniques to know about. There's this thing called Kappa, which shows you the capabilities of malware. And what it is an automated tool that does the sort of thing we were just doing manually, where it looks at the Windows API calls and deduces basically what this tool does. So you just download this thing and run it. And then you can run it on these practical malware analysis lab files. And so lab101.exe, you run it in the command line, and now it will analyze it. It gets the hash values of it, and now it puts it in the attack matrix, which I was talking about yesterday. This is the attempt to organize all the aspects of attacks and defense. And so it tells you which tactic it's doing. This does file and directory discovery, it copies files, it enumerates files, and so on. So this one doesn't do much, but it does analyze it and tell you basically what this file does. If you go to a later, go to the DIL, it tells you more. It connects, this is the networking stuff, so it goes, sends data on a socket, resolves DNS, creates a process. And there's another one here that does access token manipulation to get privileges, and it's a launcher, so it has a second file inside it. So this is a handy tool to give you a quick analysis of the basic things that happen in each file. That's a good thing to know about. The Flare VM, or Flare, whatever it is, Flare contest this year had a broken UPX packed file to unpack, and that motivated me to learn how to make your own UPX. It turns out to be far more difficult than it should be. But anyway, I eventually found somebody's high school or undergrad thesis that showed you how to do it. So you can build your own UPX with all the source code on Linux, and then you can modify it. So it's really very nice. You can build a UPX executable, and now you can modify it to do things like have different flags in it and such. So and this is something people do a lot, you can modify a UPX file. UPX files are compressed, and you can run them right in the compressed version. What UPX does is it compresses each of those code segments, like the text section, the data, and the R data, separately, and it extracts them into RAM. So you never put the whole file on the disk at all. It just appears in RAM and runs, and that's very nice. Now, when you unpack it, you can modify a UPX file so that it will run, but it cannot be unpacked, which is, of course, very handy for malware. And then you can modify UPX to defeat that and unpack it anyway. And you do some of that here. So that's one way to go. All right. And so for basic dynamic analysis, which is probably the most fun thing to do with malware, a technique you get used to. So if you have a keylogger here, there's something based on a keylogger I made key.exe. And so if you just examine it, it shows you that it uses functions like write console and get string type in the address table. And bin text shows you that it has an executable file name, vmx32to64.exe, and it has a key.exe and a log.txt. So those are files that are pretty suggestive that it's putting your stolen keystrokes in this log, and that it's creating an executable which will run here. So another clue that you often see telling you have a keylogger is you have things like caps lock, up arrow key, down. Those are the strings it uses to record those key presses. So that's a pretty strong clue that you've got a keylogger. And this is the kind of thing you get used to doing all the time. You run Process Explorer and Process Monitor. And if you have networking traffic, you might run Wireshark. Process Explorer is just a super task manager that lets you see all the Windows processes. And it color codes them, and it gives you all the details of every process, and it's in order. So the stuff up here is kernel mode. And later at the bottom is going to be the login process and stuff running in user mode after you've logged in. Wireshark, of course, just captures network traffic, and Process Monitor is probably the most important tool. Process Monitor is just a viewer of the Windows event log, but the Windows event log is far too detailed. It makes thousands of events per second and will drive you mad. Process Monitor is just a way to filter out just the interesting events and get rid of all the rest so you can find things. Now, the coolest way to use Process Monitor, which is kind of painful, is you boot it up and then you gradually exclude every process in your original system, and then you run the malware. But for simple cases like what we're doing here, it's enough to actually filter just for the key. The reason why you wouldn't do that with real malware is because the malware often launches another process with a different name. Anyway, this is the best process. Exclude all your existing processes. So you just have an empty screen here, and you see it's loading events like crazy, 863,000 events, but none of them are visible because I've excluded them all by the names of all the processes running in my clean system. And now when you run the malware, it's going to pick up all the things that malware does. So it closes a file, it opens a registry key, it creates a file. Here it is querying values. So here is creating an executable in the Windows directory. Here it creates this file, create file, C Windows VMX32 to 64.exe. So that's an indicator of compromise and an important file that's used to run the malware. And here it creates registry keys, and it's going to create a run registry key. This is the way you attain persistence typically. There are these things called auto start extensibility points. There are about 30 or more of them in Windows, ways to automatically launch code, and one of them is the run key. There's a few run keys in the registry, so it just writes a pointer to that executable in the run key, and now every time you restart your machine, it will relaunch this program. So you can test it out, you can type in keys and watch them get captured. You can see the persistence mechanism. And so even if you kill the keylogger, when you restart the machine, it will come back because it's going to relaunch that. And so you can then remove the persistence by deleting that registry key, and that'll get rid of it. All right, and there's another example, a couple of modified ones. You can look at the network traffic they produce and so on, various ones to practice those techniques. And you can make your own Windows keylogger by compiling it yourself with Visual C++ build tools here. It's another way to go. And that's, of course, how I made this stuff in the previous, for the previous challenge. Or I might have made it by basing the ones in that practical malware analysis book and modifying it to make it run on Server 2016. I don't really remember. Anyway, so that's a few more techniques.